Alright folks, hello and welcome to this video example. In this video we'll be looking at graphing a parabola using our newfound general forms in chapter 9 based on conic sections. So if you remember, a parabola is found or obtained by taking a double right circular cone and taking a cross cut or cross-sectional cut that is parallel to the edge of the cone. And when you do that, or rather this should be a plane instead of a line, when you do that, this plane will make a parabola inside the cone. And we have a formal definition with the directrix, focus, and all that good stuff. But let me remind you, because when you see a problem like this, we haven't done a ton of examples yet, or any really, other than the derivation of the TPS. So you may be curious, how can we graph something like this? Well, the first step is going to be to get it into one of the general forms we were looking at. And we basically had two general forms. One is for an up-down parabola, and that's where y is isolated. You saw this earlier in the year. We called it vertex form. And then the other one is for a left-right parabola, or one that opens sideways. And you did not see this earlier in the year, but it's very similar, except instead of y being isolated, you have x isolated. And then we have a, and then the y always goes with k. X always goes with h. So we have y minus k squared, and then we have plus h. So there's the difference there. And so you want to figure out, well, which of these equations will we be using? Oh, and for each of them, I almost forgot, a equals 1 over 4c. So then we're going to have to ask that question, what is c? Where c is defined as the number added, and I gave this to you into your notes. For period 3, it was on a sheet that was handed out the day of the sub. For period 5b, I think it was in your original notes. But it was the number added to the vertex coordinate. I'm just abbreviating here. To obtain the focus. The reason we're going to use regular c instead of just absolute value of c is because we want sometimes for a to be negative, and we want to allow it to be negative. So if we keep it defined as the number added to the vertex coordinate to obtain the focus, which I'll just call f, we end up being able to have c as positive or negative. Whereas if we put an absolute value here, it's only going to work for parabolas that are facing up or facing right. So these are the two general forms. And the next thing you want to do is think about, well, your equation is closely resembling which form? And as you can see, since the y variable is squared, we're going to want to use the form where the y is squared, or the second one for a left-right parabola. So let's look at the original problem again, and let's write down our form for a left-right parabola. We now know this one is opening left/right. But we want to, before we write down the form, let's isolate x so it looks more like the form equation that we want to get to. So let's add 11y squared to both sides. We get 4x equals 11y squared. And then we'll divide by 4 and obtain something that looks very close to our general form. The only thing is it just doesn't have all those h's and k's, but you'll see in a moment that's actually a good thing. So there's the form of our equation, and how does that compare to x equals a times y minus k squared plus h? So let's compare these two things and see if we can come up with some specs that will allow us to graph the equation. First of all, as you know, there's nothing being subtracted from y, there's nothing being added at the end here. So that is going to mean that the vertex, or h comma k, is simply zeros. And you're going to find that's the case for all of these homework problems. We're being nice to you in this section, giving you a vertex of 0, 0. When we do our examples in class, when we do more practice, I'm not going to be that nice to you. That vertex will move around. But that we can obtain because there's nothing added or subtracted to the y there. Next, let's look at this a value, this number in front. And in this case, a is equal to 11/4. Okay, that's because that's the coefficient of y squared, or the coefficient of the part with y squared in it. So we can then set that equal to 1 over 4c, and then we can use this proportion to solve for c. This will lead to 44c equals 4, which will lead to dividing both sides by 44. C will equal 1/11. That's going to be useful for graphing because C is going to help us obtain the focus and the directrix. Now that we've obtained these specs, we are ready to set up our graph. I'll do so in black and white here, and we'll label that X and Y, and our vertex is simply 0, 0. That's very nice for us. Okay, I'm not going to force you to put a scale on the graph, especially when there's weird numbers. You can just annotate with the ordered pairs, whatever you need. So we have our vertex there, and then C is 1/11th, positive 1/11th. And since we determined that this is an x equals equation, we know it opens left to right. And C is the amount added to the vertex to get the focus. So I add that vertex, remember, is 0, 0. And if we add 1/11th to it, we'll get a new point that we'll call the focus, F. And that'll simply be 1/11th, comma 0. All right, if C was negative, then I would have moved it to the left. But since C is positive, I move the focus to the right. That will mean our directrix, maybe I should use a different color. Our directrix will be on the other side, exactly the same distance away. So if that's 1/11th, comma 0, well then this will have to be the line x equals negative 1/11th. We're going 1/11th units here. This makes up C, and 1/11th units here. We went negative C in that direction. If you're talking about the distance, then yes, you can use absolute value of C to denote the distance and how it's equidistant. But if you're saying how much you move, how many units you move, it will be positive C to the right, negative C to the left in this case. And then you simply construct your parabola, which will be facing to the right, something like such, and this rough sketch will do. What I do on the homework answer key, a little bit more sophisticated, and I'm going to want you all to do it, is find an additional point that can go here and here on the parabola. So simply plug in a different number for your equation and see if you can find a different point. So for example, let's just say this is 1, comma something. 1, comma something. I'm just picking that point 1. I know this is not drawn to scale, but we can plug in a 1 for the x now, our x coordinate, and we can solve for the y coordinate. So 1 equals 11/4 y squared multiplied by 4/11. 4/11 equals y squared. Take square roots. Don't forget your plus or minus. Y equals plus or minus square root of 4/11, which is square root of, square root of 4/11. Square root of 4 over square root of 11. Let's bring it back up here. And that's going to come out to, let's see, plus or minus 2 square root of 11 over 11. And that'll be your other coordinate here. Is it pretty? No. Could we estimate it with a calculator? Yes. Okay. Sometimes for graphing I will permit calculators. Sometimes I will not. So you should be able to do these numbers, which are not too bad, without a calculator. Hope this helps with the homework, and thanks for watching this video example.